All right. Welcome back, guys, to Foundations of Programming, Day 10. We're going to pick up from where we left off, which was classes and objects. Yesterday, I believe we finished taxi cab. And as a matter of fact, the next thing in the curriculum is actually another assignment. So let's go ahead and open up our directory. The assignment is going to be the stddev.py. I think standard deviation is what it stands for. I'm going to share my screen. The assignment we're going to start off with today, it's going to be the standard deviation.py. This is actually the one that I hate doing. I always have to look up what standard deviation is, if I'm being honest with you. But let's go ahead and open it up. We have standard deviation here. And we're going to have a link here that's going to explain a little bit better than what the README does. But once again, you're going to use your classes and objects, everything you learned so far, to kind of expand on that and put it in practice. All right, so you're going to write a class that's going to be called person that has two private data members, right? The person's name and the age. It should have an init method that takes two values and uses them to initialize the data members, right? And it should have a getAge method. So you already know you have one class here, which has two methods. One is the init method, and one is the getAge method, right? They're going to write a separate function, not part of the person class, called std_dev, which stands for standard deviation. That takes a parameter, and this parameter is going to be a list of person objects, right? A list of person objects, and returns the standard deviation of all their ages, right? So the population standard deviation that uses a denominator n, and this maybe not the big example. Let's go ahead and open up this link so we can see what it's trying to tell us. Right, this link's going to send you here, and this is going to explain a little bit better what the standard deviation is. But the standard deviation is the calculation of the dispersion or variation in a set of numbers, right? The standard deviation will be small if the data points are close to their average value. Additionally, the deviation will be large if the numbers are spread out further from the mean or average, right? A lot of mumbo jumbo for simple formula. Now, to calculate the standard deviation, you have the steps right here, right? The first is going to be to calculate the mean. All right, so simple average of the numbers. Well, in the context of this assignment, the numbers that you're going to be taking is going to be the age of the people that you have. So you're trying to find the standard deviation in the age of the person objects, right? And as you already know, we should have multiple persons within a list. They're all going to have a name and age, but we're trying to find the standard deviation of the name of all these person objects, right? They even have the formula here, but I feel like it's better explained within this page here, where first you want to calculate the mean, right? So you already know you're gonna have to grab all the ages of all these objects, and you're gonna calculate the mean. And the mean is just a fancy word for the average, right? The average age of all these people. For those of you who have not done math in the longest time, you essentially want to grab all these numbers, you want to add them all up, and then divide by how many numbers you have. So, for example, if there's 5 objects, right, there's going to be 5 ages, right? It could be 18, 25, 40, 55, 60, whatever it may be. You need to add these numbers up. And because you have 5 people, after you add up these numbers, you're going to divide it by 5, which is going to give you the mean or the average of all these numbers. And then for each number, you're going to subtract the mean and then square the result. So you know after you get this mean, you're going to have to, once again, loop through all these numbers, these ages, and you're going to subtract what the average is from those numbers and then square the result. Then calculate the mean of those squared differences, and that is going to be the variance. You're going to take the square root of that to obtain the population standard deviation. This is going to be that additional function that you have to create that's not a part of the class, right? This is going to be your standard deviation function, and this is how you calculate, right? So you're going to take these instructions and then use code to reach this outcome. Make sense so far?
So, I mean, I understand the definition. The definition is a lot simpler, I mean, in line five. I guess are we just being extra challenged with all the steps? Because if it's as easy as number five, why wouldn't we just do five, line five?
This does not cover every single step, right? So to calculate a standard deviation, you'll need to take a square root. A square root of what? Right? Which you can do by just using the exponent of 0.5. So now you know how to use, you can square root by
Okay.
multiplying by 0.5. For
Oh,
example, the
I
result,
see.
right? So
Okay.
this is not like a complete explanation of the standard
Oh,
deviation, which
okay.
is why you have the website. Make sense?
Yeah, I understand now.
It
I
just
was, I was trying to use a cheat code, didn't work.
it's okay. This line five is going to explain to you how you get the square root of something, right? Essentially, you use an exponent. So you're going to do, for example, if you have 9 and you want to get the square root of 9, you're going to do 9 asterisk asterisk 0.5, and it will give you the square root of 9, right? This line 5 is just explaining you how to use the square root in your standard deviation function. Make sense? Python does have a specific square root function, but that involves importing module, which we haven't covered it. Technically, I did cover it with you guys, but try not to use this, please. Use this part right here. Essentially, you should be able to create multiple objects. As you see here, we have 3 objects. You have a list here of those objects that were created. And then you take the standard deviation function and pass in the list. Once again, that list should be able to grab all these people objects and then return to you the standard deviation. Does that make sense so far? Do I have any questions? All right, let's give it 15 minutes and then we'll code it out. Let me go ahead and pause the recording. All right, let's go ahead and come back, guys. Let me go ahead and start sharing my screen. We're gonna go ahead and code along to this assignment. Okay, so the first thing we are going to do is we're going to create our person class. So we're going to start with class person, and it's going to have 2 different methods. The first method is going to be the init method. So we can initialize our class. It's going to take 2 arguments, right? The one argument is going to be the name, and the other one's going to be the age. So we're going to say name, comma, age. Finally, we have to assign them, and because they're private, we're going to use the underscore and say self dot underscore name is equal to name. And then self dot underscore age is equal to age. Next, we're going to create the second method, which is a get method to grab the age that corresponds to this specific person. So we'll say get age and the required self, and we're going to return self dot underscore age. Right, and that concludes the person class. Before I do the std_def, I'm going to make sure that my person class is working. So I'm going to say, I'm actually just going to go ahead and copy these 3 here to save myself some time to instantiate my person objects, right? So here is the person class, and each one of these person classes that I'm calling all have their individual name and their age, all assigned to variables. Now, if I print P1, P2, and P3, now run this, I should get back the objects with their weird, uh, print statement that shows me the class that they are, as well as the fact of where their actual location in memory is at. Go ahead and cd into std_def, and I'm going to run std_def.py. And we see here that I am able to print out my 3 objects. These objects were successful. And then let's also grab the age for one of these. I'm going to go ahead and say print p1.getAge because it's a method, It's essentially a function, so I have to use the parentheses, run it again, and I see that I get 73, which matches the age for my person. So my class is able to instantiate a person object, and I'm also able to use the method to get the age. That takes care of the first part. Now, let's get into the functionality of stddev. As we mentioned before, stddev needs to be a separate function, not part of the person class. So it's as simple as going to a new line and unindenting to come back to the original global scope of my code. And I'm going to define this function. So define std underscore dev, and it should take a couple parameters. As a matter of fact, it's going to take one parameter, right? It takes as a parameter a list of person objects. So I'll just say list of person objects. Maybe there's a better way of describing this parameter, but this at a minimum tells me what this should be, right?
Do you have to start your, do you have to define your STD dev underneath your instantiation of those P1, P2, P3? Or does it matter?
I don't think it matters. We'll mess around with it in a bit, but just for the sake of this, I'll just keep it here. Afterwards, I can move it and see if it's still working, but it
I
should
mean,
not matter.
I thought pretty much function. You said JavaScript hoists functions to the top, and you said Python. It pretty much reads top to bottom. So you pretty much need to define the function before you can, call it.
So if I call it, I have to call it after the definition of person,
Yeah, yeah,
right?
yeah.
But
That's
the
what I'm saying.
definition, I don't think it should matter because this is just telling it what it should be, but it's not running it, right? So this is under the
Yeah.
impression that whenever this function is ran, this has to be something, which I'll explain it a little bit. Let's hold that thought, and then I'll get back to that explanation. Sound good?
Yeah,
Yeah.
I think I get what you're saying, but yeah.
So I know I'm under the impression that this has to be a list, and I think I could do something like list. How do I do it? I guess I can't do it. Um,
So
no. How do?
what I
There's a
did,
way.
I called the actual parameter here, whatever I called it, and then I just said equals default value of the list, which was created from P1, P2, and P3, and that worked.
You're saying you're adding a default value here?
Yeah, I added the default value. That way, when I called it, I didn't need any arguments.
Okay, I mean that's one way of doing it. But I want this to be dynamic for me to be able to uh not just use this specific list, but any kind of list of person objects. Which is better practice than just hard coding the default. But I can see why you did that.
I just did it to make sure that it would work quickly.
Fair. That's fair. And this should be, I think the syntax is list. Yeah, there we go. This tells me right here is that list of objects has to be list type, right? So you can do something like this. You can even say something like names string. So you can specify whenever you say your parameters what type of data type it should be, which just gives you a better understanding, um, or it gives you a hint of what parameters it should be taking. So you can do this if you like. But this here tells me that list of person objects is a data type of list. Make sense?
Can you do that in JavaScript? I mean, I know like we normally like by best practice, you would name it like string, array, object, whatever type of parameter you need. But, I never saw it like being like hard coded, like, as far as like hard coding a list, as in like if somebody would have been something else, it, wouldn't work or whatever.
Um, I don't know. I've never really done it with JavaScript. And that's probably one of my biggest weaknesses is that I don't focus on front end and JavaScript too often. I know it enough to be able to work it, but I wouldn't call myself a subject matter expert in JavaScript. I feel like I'm a lot stronger in Python, so I know stuff like this. I would have to do a quick Google search for that in the terms of JavaScript. I would say you probably could do something very similar to this. And you've probably seen it whenever doing leak code problems. Or something very similar to LeetCode, they'll have like some kind of array function filled out for you, and you probably see something like this, right? I'm sure you've seen something like that, or you've seen probably something like S string, right? You probably see something very similar to that. But let's go ahead and move forward. We have here our function that's supposed to take in a list of objects. Now let's handle the actual explanation of how to work with stdef. I copy and paste this from the website to give me a better idea of what I'm working with. And these are all the individual steps. And the first part is going to be to calculate the mean of specific numbers. Well, I know that I want to calculate the mean of these ages. So this is going to take in a list of different objects. And to grab the age of every single object in here, I'm going to have to loop through this list, grab the object, and then use the getAge function to grab their age, right? So I can say something like total age or age total is equal to something, right? Which right now is going to be 0. And I'm going to do it very deliberately here, line by line. So as of right now, my age total is 0. I'm going to loop through for person in list of person objects. This is going to allow me to loop through a list of different objects. That object is going to be assigned to this variable here called person. And then I'm going to say age underscore total plus equals person dot get age. Right? I'm going to add what comes back from the get age method, right? Because this will return to me, as we saw earlier, the age of this object, which I'm just going to go ahead and add to age total. And once I have the age total, I'm going to say age mean is equal to, and as we know, as I described earlier, to get the average of something, you take the sum, which in this case is going to be our age total, divided by how many of those items you have. So this should be age total divided by the length of list of person objects, which should give me my mean. Is everyone still with me?
Yeah, I just did. I felt like I was working through the standard deviation function. 15 minutes, I couldn't complete it, but I felt like I was making headway.
Okay. So this right here, this takes care of step 1, calculates the mean of the ages, all in these 4 lines. Now let's go ahead and move forward. Step 2, which is for each step 2, subtract the mean from each age and square the result. So once again, I have to loop through these objects, grab the age, and for each age I get, I want to subtract the mean from it and then square the result that I get, right? So once again, and I'm doing this very deliberately, there's definitely a better way to do this all within one for loop, but I'm taking it one step at a time. Let's go ahead and say for person in list of person objects. And then I want to grab each number, subtract the mean, and then square the result. And probably save this result somewhere. Right? Because then I have to calculate the mean of those square differences later on. Calculate the mean of those square differences. Yeah, so I'm going to have to create some kind of other variable where I can store the result of subtracting the mean of each age and then squaring it, right? So I'm going to say squared age is equal to an empty list. And I'm going to add the new result of these ages within this list here. So once again, coming back to the for loop, after I get the age of every number, I'm going to subtract the mean, right? So I'll say temporary diff is equal to, and we'll say person dot get age, and then subtract the mean minus age total. Right, and then I want to add this into squared age. And as a matter of fact, I could probably do something like squared age dot append and I'm going to append the result that comes back from this, where I grab the age, I subtract the mean, and then I have to square the result. So I might have to add some other functionality here, where
You're
after I get the
you're
result.
subtracting the total here instead of the age mean on that line.
Thank you. Thank you very much. Yes, you're right. I almost made a mistake here. The mean. I don't know why I got the total. I think. Thank you very much, Tim. I was getting tunnel vision, but you're correct. I'm supposed to subtract the mean from the age, which we're doing now, and then I have to square that result, right? And as we saw here from line 5 on the README, to get the square root of something, we want to do the double asterisk and then the 0.05, right?
But aren't you supposed to square it, which means multiply by itself? So times double asterisk 2 instead of 0.05. You take the square root later in the function.
Yeah,
Is it
yeah.
square? Okay, thank you. You're right. Hey, math is not my strongest suit. So we squared, so it should be times,
It should be double asterisk 2.
yeah, double asterisk 2 squared. Thank you. Hey, man, I don't get paid for math, but thank you. I hate this problem so much. There we go. So, yeah, we square it. And then that should conclude step 1, right? Because we go through all the ages. We subtract the mean from each age. We square it by 2. And then we're appending it to this list of squared age. And then we have to calculate the mean of the squared differences, and that's going to be the variance, right? So this should complete step 2. Let's go to step 3 and say calculate the mean from squared age. And that's all it wants to do. Take the square root of that to obtain the population standard deviation. All right, so let's go ahead and go and get the mean of squared age is equal to, let's say, 0. And once again, how do we get the mean of something? Well, we have to add everything together and then subtract the differences. So I can say total squared age is equal to 0. And then we're going to say for age in squared age, total squared age plus equals age. And then once we get the total of that, the mean of that is going to be total squared age divided by the length of squared age. Does it look right so far? I think I'm on the right track here. I know we can get very confused with all these different variables. But it's
Do we need to, or do we want a float or an integer for the result of these? Do we care? Because at the end, when I did this, I rounded everything. I converted them to integers so that there would be a nice clean integer. Otherwise, I got a nice decimal that I didn't like.
we'll keep it to the decimal amount. It doesn't really specify to how accurate we want to be with it. But for the sake of just keeping the raw data, we'll keep it to a float if it does return a float.
It does.
Right? Because when you say it does, do they ask for it somewhere?
No, I'm just saying it does return a float. It doesn't specify
Okay.
either way.
It doesn't specify in the README, so it's not a topic of concern. But if it did, then yes, we would want to convert that, right? But we want to calculate the mean from squared age, which we know it's a list of different numbers that I already went through some kind of formatting. So we have to get the total of everything in there. So we loop through the list of squared ages, and then we added each age to a variable called total squared age, which we then use to divide by the length of this list to get the mean of that. And that takes care of step 3, which brings us to step 4, which is take the square root of that to obtain the population standard deviation. So square root the mean of squared age to get standard depth. So we'll say answer, or we'll say result. Result is equal to mean of squared age, double asterisk, or 0.5, I believe is what it was. Yeah. And then we can return results. And that looks like that should complete the formula for stdef. Let's give it a try. Let me go ahead and lower this so it doesn't get in my way. I'm gonna go ahead and I'm gonna add my list of objects is equal to P1, P2, and P3. And then I'm gonna print out the result that comes from stdef. And this takes a list of objects. And let's run it. Hopefully you guys got something very similar to this. Did anyone get something completely off? Am I completely off?
No, you're right.
Okay,
I just converted it to an integer and made it 20.
that's fine. Jason, Chase, any questions? Are you guys completely off?
Can you just give me 1 second and I'll
Sure,
run it.
sure thing.
Alright.
I understood the math part. I just missed yesterday's class and didn't watch the full video yesterday. So like the actual like function part, I was just kind of going off of the slideshows. So I got like the setup, but then the actual other stuff I didn't quite get. But that's where I'm gonna like finish watching the video from yesterday this weekend and then do this problem on my own.
Okay.
Yeah,
Is there anything? Is there anything?
I got that. I'm good.
Okay, awesome. Sounds good, Jason. So we're good with Jason. Chase, is there anything here that you would like for me to kind of explain real quickly that might help some confusion that you might have?
I mean, yeah, I kind of understood a lot of it as you were going through. The one is there when you do the function for standard deviation, it says list of person objects. I was a bit confused on where you got that from.
Yeah, so that's coming from the fact that the way the standard deviation works is that it takes, right, to get the variation, you want to get the variation of a bunch of different numbers. This problem specifically asking for us to get the deviation of the ages of all the different objects, right? Of all these different person objects.
Yeah.
Well, I mean, it doesn't have to be a list of person objects. I could have honestly done something like this where I would just grab the age of every single person and put it in a list. But it made it easier if I just put all these different objects within a list, right? And then just pass that all into this this function here. But regardless, I still needed to get the age, right? So the list of objects is coming from the fact that I created 3 different objects and then I just added those objects into a list myself, right? And I'm passing that into this function. This function is going to grab every single object within that list and run the get age method.
Okay, wait. So I think I understand. So that when you run the function and you have list of all the people, and then you just the actual function, it just kind of rechanges that variable from list of persons to list of person objects.
Yes. I'm just calling them 2 different things, right?
Okay.
But this list of objects is taking the place of what's supposed to go here, which is a list of person objects, right?
Yeah.
But these are the same thing. I just call them differently when I created them. I mean,
okay,
I could be very specific. I can say list of person objects because that's technically what it is, and it will still work, right? List of person objects.
Okay, and the way you explained it made sense, so I do appreciate that.
Yeah, no problem. But we're able to do this because just like when you loop through a list of like strings, right? You're able to do things with those strings, right? When you loop through a list of integers, you're able to add those integers. This list is just a container. It's just holding a bunch of objects together. And each object has the ability to use the get age method, right? They are their own unique object. So they all have a name, they all have an age, and they all have the ability to use the get age method. So I take advantage of that. I loop through this list to grab every single object, and then I invoke the method that each of them have, which is get age, to grab their age. Right? And just a little bit more explanation on exactly what is happening when creating objects and stuff. Let's go back to our handy dandy TL draw. Right? And I have this blueprint, right? I have this blueprint, and this blueprint is my class of person. Right? I create some kind of instruction or blueprint, and this blueprint tells me how to create a person, right? This person has a name and it has an age, right? Within the init method. This person has some different kind of abilities, right? They have abilities. They have things that they can do, just like you do. You can walk, talk, run, sing. You have your own special attributes that you can do. So does this person. Maybe it's not the best analogy to use this, but I like to think of it as if like you were a creator, right? Like if you guys, I don't want to get into politics, religion, and stuff like that, but I just like using the analogy because it makes sense to me. If I was the creator and I want to create a person, right? Maybe I can create some kind of blueprint or a template to make every person, and then after I have some kind of template, I can give them some individuality, right? But this blueprint is going to allow me to just create multiple people to populate my world, right? In essence. And the ability that each person should have is the ability to tell me what their age is, right? So that's the get age method, right? And all this method is, it's just going to return to me their age, right? This is what a class is. Essentially, these are instructions, a blueprint, a template of what your object should be. Now, using these instructions, I am going to read through the instructions and create an object, right? This is the class. Now, I'm going to use this class or instructions to bring my object to life, right? And this, in turn, uses this blueprint to create a person object, right? This person can be called Jason, and he is the age of, let's go with 30. I don't know your age, Jason, but I'm gonna give you 30. Right? This is one object. I use this blueprint to bring something to life, which is my object named Jason with the age of 30, and he has some type of functionality. He comes with the ability to tell me what his age is. Right? And now I created multiple different objects, right? But each one of these are a little bit unique. One is Kenny. Right? Kenny, I don't know how old you are. I'm going to say 25. I have Chase. He's going to be 40. You don't look, I'm not saying that you guys look these ages, right? I'm just giving you an example of specifics here, right? I created these multiple different objects using the exact same template, right? And all three of you guys all have these same abilities. Then I wanted to categorize you or put you guys together so I can do something in mass, right? So I created a list of person objects, right? And I put all of you guys inside of this list, right? That's what essentially happened. I created a list of person objects, and then I have some method or some function somewhere that should be able to identify the STD dev of all your ages, right? So I have this function over here, STD dev, and it takes a list of objects, right? Which is essentially all of this. I invoke a method in you that you guys all have, right? I started for loop so I can grab every single one of you guys individually. And then I use the get age method to get the age of Jason, which is 30, the age of Kenny, which is 25, and the age of 40, which is Chase, right? And then now that I took advantage of the ability that all every single one of you guys have, I use this information to move forward with the function, right? And that's pretty much how all this worked, right? Of how the class is able to help me make multiple versions of you guys that you all have different types of data attributes and abilities. And I use that to be able to do different other stuff, like get the standard deviation of your ages. Does this kind of make sense to you guys? Is there any questions? Kenny asks, is that function supposed to be tabbed outside of the class? Yes, it is, right? This is a individual function itself, right? Functions can take in objects, right? Just like you saw here. Just like functions can take integers, strings, lists, dictionaries, they can also take a list of objects. All right, let's go ahead and go on our first 10-minute break. Time is 6:37. Let's come back at 6:47 and we'll continue with today's class. All right, let's continue with today's class. Give me a second. I have to sneeze. All right, sorry. I don't like blowing up the mic. Can everybody hear me?
Yeah, we heard you sneeze.
Oh, what the heck? I'm sorry. All right. Okay, well, let's go ahead and continue. We have the next slide here, which is passing objects as arguments. All right. So objects can be passed as arguments to any method because everything in Python is an object. This is an abstract concept, so it's okay if you don't understand it completely yet, but you are able to pass in these objects. And let's look at that real quick. We'll see it actually. We'll code it out together. All right, so in your Python file, I want you to go back to your classes and objects again. We're gonna go ahead and come back and kind of continue with the lesson and learning new material. And what we are going to do is we're going to create the pet class again, right? So I want you guys to go ahead and make sure that you have your pet class. And it needs to be something very simple, right? So we can really, we're going to focus on creating classes. We want to focus on the main topic, which is make other classes create other objects, right? So we have class pets. You should be able to initialize it, and it should just have a name, right? And then self dot name. Don't privatize it. We'll just keep it simple right now. So we don't spend too much time on this. And then we should have a method called get name, which should return self.name. All right, so here is our pet class, straight and simple. Now we're gonna create a second class here, and this class is gonna be called home, right? A home class to simulate a home object, right? Like everything else, it needs an init method that's going to initialize our class. And when we initialize it, it should be able to take in an owner, right? Who the owner should be. So self.owner. Chase, did you get to the part when I discussed about privatizing attributes or no?
I had not. I watched like an hour's worth of the video.
Okay. So essentially, I'll cover it real quick. The way that I create this attribute right now, anybody has access to it, right? And I can show you real quickly. If I were to do p1 or pet underscore 1 is equal to, and I call the pet class, to instantiate, it takes a couple of attributes. This one specifically only takes name, right? So whatever you pass into these parentheses is what the attribute that this class is going to take, right? So for this example, I'll say it's going to be Oliver. That's the name of my dog. So when I create this pet, if I print out pet underscore one dot name, you will see that I can grab the name of this object, right? And that can become an issue because people can do something like this where they can say pet underscore one dot name is equal to max. And if you see, if I print out pet underscore one dot name again, you'll see that it was Oliver, and then someone was able to manipulate this object directly and change the name to max. And that's not always good. You don't want everybody to just be able to manipulate stuff. Because what if you had a class of a bank account, right? And one of the data members that it had within the init method was like your account balance. Someone should not be able to manipulate something like that, right? So the way that you prevent other people to just manipulate your data attributes that should not be manipulated is by privatizing it. And Python doesn't have a specific declaration to do that. The way that we do that is by adding 2 underscores before the attribute name under the self dot declaration, right? So now, as you see here, these are whited out. I can no longer access them the same, right? I can't even say print pet underscore one dot underscore name. I guess I can. Let me see. No, see, when I try to do that, I get an issue. Right? Pet object has no attribute underscore underscore name. So that keeps people from just directly manipulating data attributes, right? So when I say privatizing a data member, this is what I'm referring to, adding 2 underscores before the variable name on the self dot side, right? And this is the same as declaring a variable. We use the self prefix to specify that this variable specifically belongs to the class of pet, right? It's almost like talking in third person, like, hey, myself, I'm going to have this attribute called name, and the value is going to be the parameter of name that's being passed within the init method, right? The init method automatically runs by default the moment that you create a class, right? Init methods run automatically. You don't have to call these methods. And methods is just another fancy word for a function, right? So this function right here runs automatically the moment you try to instantiate an object. And now you're kind of up to speed on that aspect. So let's go ahead and move forward with the class of home. This is going to have a self.owner, and we're going to assign the owner parameter as its value. And we also going to have another attribute, right? But this attribute is not going to be optional to be given as a parameter. By default, when we instantiate a home object, it should already have a list of pets as an attribute, right? So this home should be able to take in pets, right? By default. It won't have any pets automatically, but it should be able to say pets as an attribute within this object. Now, let's go ahead. I'm going to create pet1 is equal to pets, Oliver. And I'm going to create a home. Home1 is equal to home. And this is going to be my home. So I'm going to give it the name of Roger, right? For owner. Right? So this right here, because I pass in the argument of Roger, that's going to take the place of owner. It's going to be saved to this attribute called self.owner. I can say print home underscore 1. And we'll see that it prints out the object of home. Well, what if I do dot owner to grab the owner attribute? I can see that this belongs to me. Okay, cool. What if I do dot pets? But when I grab that attribute, I see that it returns the list. So I'm able to see what kind of pets this home has. As of right now, it doesn't have any homes. Well, I'm sorry, it doesn't have any pets. Well, let's add a method to be able to give the ability to home to adopt a pet, right? So we're going to go ahead and define a method, right? Not an independent function, this object is going to have a method that's going to allow it to take in a pet. And it's called adopt pet. Right? This method, once again, it requires self, but it's going to take in an object as an argument. Right? This object class is going to have a method called adopt pets, which can take in another object as an argument, and it's going to use that object to save it into its pets. So we'll say self.pets dot append pet object. Right? And then we can create a different method that's almost like a getter. It's almost like a get method called show pets that's going to return self.pets. Right? So once again, if I run this, currently the pets in home 1, there is no pets, right? This home specifically has no pets in its record. There is some dog out there called Oliver, and there's my home that I own. Well, I somehow encountered this pet called Oliver, and I want to adopt him. So I'm going to say home_1 dot adopt pet, and I'm going to pass in pet_1. And now if I print out my pets, I can see that the show pets returns to me a pet object. Right, so there is a pet object, and notice that in brackets. This is the list that's saved within self.pets. I successfully took in an object using a method and saved it into one of my data attributes. So we can pass in other objects into a different object so they have access to it. Does this make sense to you guys? Now, this isn't really readable. Let's add some dunder methods to make this a little bit easier to understand. In my pet object, I'm going to manipulate the response of what happens whenever I print out this object, right? Because right now, when I do print pet_1, when I try to print an object, Chase, it gives me this hash, right? This is the response that you get when you're trying to print out an object. You know, when you print out a string, it'll print the string, its raw string. When you print integer, it gives you the integer. If you print a list, it gives you the list. But when you try to print object, it doesn't give it to you how you would expect. It has some weird code here, which is like a hash object. It tells you it's a pet object and it's at this location in my memory. And that's not very readable to me as a developer. You're able to override this response whenever you print an object by manipulating that in the class itself. So just like we have this init method, we have a different method called _string_, right? This method is called a dunder method, right? Dunder methods get the name because they have double underscores before and after, right? Hence the name dunder, double under. This method specifically, by default, it already has some functionality, which is the ability to print this out right here. But I don't want it to return this to me. I want it to return something else. So instead, I can call the method and override it by saying return self.name. And I am getting an issue here because I don't have self in here. There we go. So now whenever I try to print out a pet object, it won't give me this hash. It's going to give me back whatever I'm returning from the string method. So we see here, when I try to print out pets for Oliver, it actually gives me what I added there. For some reason, that's not doing that within the home class. I don't know why. Interesting. Maybe because it's a list. What if I say no?
Yesterday you did string interpolation when you showed us the string method. I'm not sure that has anything to do with it though.
It's probably because it's within a list. That's what I think it is. That it's not printing the dunder method out. Right? Because if I say 0, there it prints out Oliver. But because it's within a list, I'm printing out the list. It doesn't run the string method on that pet. Make sense? But anyways, we're able to create a different object that has a method that takes other objects as arguments and is able to do stuff with them and even save them within its attribute points. Is there any questions on the fact that objects can take in other objects?
I mean, I think that'd be useful to know how to figure out how, I mean, maybe if we have time.
What part? This
This
part?
this yeah, the self dot pet, so you don't have to call it by an individual pet, but let's just say you had a bunch of pets. It will read all their names off as opposed to you having to index it to see like just one of them at a time.
Well, let's see. Maybe we could do some pet self dot pet for pet and self dot, or we can say pet for pet and self dot pets. Oh, this is the wrong place. I'm doing this. My bad. Maybe I can do that here instead of just returning the list of self dot pets. I can say pet for self or for pet and self dot pets. Let's see if this works. No, it's because of the list. For pet and self dot pets, print pets. Yeah, it's the way that I return it. We'll return none, but I mean you can print them out. It's just because it's saved within a string. Uh, but we'll take care of that later. I don't want to go down a rabbit hole. But I'll owe you an answer to that, Jason. All right, moving on. So we saw here that I was able to create a pet. I was able to create a home. And this home was able to create a method that takes in the pet object and saves it within this object in this list, right? Now, just like we can take in objects as arguments, other objects can create other objects. We're going to create a class called club. And this club should have a title. Self dot underscore title is equal to title, right? Then we should have a method to get that title. Define get title. And this is going to return self dot underscore title. So Chase, these are what we call get methods, get and setter methods, right? So going back to privatizing data attributes, we mentioned that we don't want people to directly access certain attributes because they can manipulate them, right? So how do you allow people to view attributes without manipulating them? Well, for one, you would privatize them, but then you create a customized method to allow them to still view the data but not manipulate it, right? So just like I privatize the title attribute here, I still want them to be able to see the title, just not actually change it. So we create a method here to allow them to view it, but that's it, nothing else, right? That's what we call a getter method. Now, if you want them to be able to manipulate it, you can say set title, and this is what we call a setter. where you can allow them to manipulate it by passing in arguments and then saving directly that argument they're passing in to override that method or that attribute, right? So this is a getter and this is a setter. So normally you want to privatize everything, let them get the attributes, and only specific attributes should be able to be overridden at your command, right? You should only let them set certain attributes that you are okay with. But here we have this club, and we can say chess club is equal to club with the title of chess. And now if I print chess club dot get title, I can see here that I do have this club, and it has a method called get title, which allows me to get the name of the club, right? So we have a club here. But we don't want to manually create it here. Let's go ahead and create a different class. And this class is going to be called Club Association. Right? Kind of like the HOA, right? Just an association that manages all these clubs. It's going to have an init method. And it doesn't need any specific title, right? There should just be one overall club association that manages all the different clubs. Right? So when we instantiate this club association, by default, it should have a data member called recognize clubs, and it should be empty. Right? So when you first create this club association, obviously there's no club that's registered with them. So by default, when we create the club association, it should be empty. We don't recognize any clubs at all. But at some point, as clubs start emerging, we should be able to add a new club into our association. So we should create a method to do that. So we're going to say add new club. And this new club should be able to take in, or this new method called add new club should be able to take in the title of this club and add it into our list of recognized clubs. So this method should say new club object is equal to, and we're going to create a club, and this should take in the title that we're trying to create. Right? So whenever someone wants to create a club, they don't just magically create this in their basement. They need to come to the club association and register with us so we can recognize who they are and make them legitimate. Right? So the club association object will have a method to be able to register a club and make them legit. So when they come to us, they're going to give us a title of the club they're trying to create, and then I'm going to register them and make them legit. But after I create them, I also need to add them to my ledger of recognized clubs. So after they're created, I'm going to say self dot recognize clubs dot append new club object. And then I shall also have another method that allows me to see all the clubs that I have in my ledger. By showing me my list of recognized clubs, right? So now that I've created the system, let's go ahead and create my club association. I'm going to say club association is equal to, I'm going to call the class. There's no specific name to this. It's just called the club association, right? Chase comes in and says, hey, I want to create a club for chess, right? And I need to register with you. All right, Chase, sounds good. What do you want to call this new club? Well, I want to call it a chess club. All right, cool. Well, let me go ahead and register you. So I'm gonna say club association dot add new club. And you said you want to call this chess club, Chase? That's correct. All right, cool. Chess club. All right, you have been registered. And then I go, I go about my business, and I've collected some clubs. I'm like, all right, well, I want to see what my clubs are. How many clubs do I have right now? Well, let me go ahead and see all my available clubs. And we can run this. And we see here that I can see that I have one club saved within my ledger, right? So I was able to create a specific object of a club association. I myself, the club association, was able to create a different object and then save it, right? Now, if you wanted to have access to these, how would you want to, like, if you wanted to grab this club and do something with it, how would you do that? Let's say we created another club, right? And this is going to be the, I don't know, the hockey club, right? And let's say we created a different club, and this is going to be called the art club, right? I have multiple clubs. But let's say I want to do something specifically with the art club. How do I grab the art club? Now that's your question. How could I grab this art club and then do something with it?
Just the get method.
The get method. Which
Well,
method?
like as in you know the get they just get and then return the name at least to get the name of it.
Well, there's no get method in the club association. We have list available clubs, right?
Yeah. Sorry, I was just kind of mentioning how you said like get that, to get underscore, and then throw in a name.
We could make a specific method, right? As of right now, I don't have that method, so I would have to be a little bit more deliberate. I would have to say something like for club and club association dot list all available clubs. If club dot get title is equal to art club, my art club is equal to club. Print my art club dot get title. Object is not iterable, but it's a list though. What are you talking about? List all available clubs. Oh, my bad. This is printing, not returning. Let's go ahead and change this. Let's say return. I don't have access to it here because all I was doing was printing it, but this wasn't returning to me the list. And there we go. Right, so yeah, we obviously, it would make more sense, right, Jason, to create a get method to grab a specific club. As of right now, my functionality in my class did not have that, so I had to look through the list of all the clubs, which we know we can grab by calling club association dot list available clubs, and then I'm going to check which is called the art club, and then save it to a variable, and then I can use something with that variable, right? So that's one way of doing it. Or you're absolutely right, we could do a different method that says get specific club by like title, right? And then we could add the functionality there where we say for club and self dot recognize clubs, if club dot get title is equal to title, return club. Right? That's probably the more legit way of doing it, right? Where we could say my art club is equal to club association dot get specific club, and I want to grab art club. Let's go ahead and print my art club dot get title and see if this works. And there you go. So that is a more effective way of doing it, Jason. Yes, you were correct. Right, you would want to have that functionality in the method for the club association to kind of isolate that code somewhere, give that functionality to your club association so you can just do this for other stuff, right? So that was the best way of doing it. Do you have any questions so far about creating objects of one class inside of another? Okay. All right, so we have our club here, and we have the club association. We can use objects of one class inside of another. What if we had a method called getTitle or checkTitle? Right, because as of right now, we saw that when we printed out the recognized clubs, it didn't look anything readable, right? But I mean, you kind of already saw how we were able to use that club title here. So this kind of goes hand in hand. It's pretty much the same thing. But we create a method called self.check title, and then we can say for club object in self.recognize clubs, if club object dot get title is equal to our club print yes, that is a recognized club. Right, this is very specific. So let's go ahead and say title and change it to title. So we can check if this club association has the art club in it. Yes, that is a recognized club. So as you saw earlier, I'm able to use the methods of one other object inside of another object. So this object can create other objects, you can access those objects, and even utilize their own methods of that object of club inside of a different object. Because you have access to them. Does everyone understand this concept so far? In summary, you can use objects of the same class or another class inside any method, right? We're able to create objects within an object, use that object that we created within this object's methods, right? A method can accept an object of any class as a parameter in the same way it could accept an integer or a string. By default, a method will always have a self parameter, and self will reference the object on which the method was called, right? It uses the self in a way that it talks about itself in third person to say that, hey, I'm going to create this data attribute, or hey, I'm doing this. When a method takes an object as a parameter, you can call methods on it that are defined for that class. Now, everything we just talked about, we're going to put it together in one assignment using the line segment.py. Let's check it out. Maybe it'll make more sense once we actually start working with it. It's a lot, right? All right. So I would kind of go through this one by one. But this is a very complex assignment. So what I recommend is take it from the top, one like line by line, right? Step by step. Right. Remember that all data members should be private. An object can access its own private data members directly. It can also access the private data members of other objects of the same class directly. But when accessing a private data member of an object with another class, it needs to call the appropriate get method, right? So you want to use get methods, setter methods. Just remember this: if a method is the same class as a private data member, then it can access that data member directly. Otherwise, it needs to use a get method. Right, so you're going to write a couple classes here. You want to write a class named point that has two data members, which is x coordinate and y coordinate. Right, that's going to represent a specific point. Afterwards, you're going to create a line segment that has two data members, endpoint 1 and endpoint 2. representing the two endpoints of the line segment. So these are going to be objects themselves. Both of these objects together make another object called a line segment. Right? The init method of this line segment, it takes 2 point objects as arguments and uses them to initialize 2 data members. Right? So we should have a point object and then a line segment object that's going to take these points to create a line segment. Right? After we create the line segment, we should be able to have a method that says is parallel to. This method is going to exist within the line segment class. So this line segment can compare itself to another line segment to see if they're parallel to each other. Right? It's going to have other methods like checking its slope. Here's a very quick example, and you'll understand it more as you read it. But here we have 2 point objects, and they're objects because you can see here that they're calling the point class. It takes an x and y coordinate to specify what point it is. Right? We're able to compare distances between points. We see here that point 1 is calling a method called distance2, and it takes in a different argument to compare the distance between one point to another. Right? So the points are going to have their own method, like distance2. Afterwards, we can use those points to create another object called line segment. And notice that when we try to call the line segment class, we take in 2 arguments, which is point 1 and point 2, which are both objects themselves. This line segment can tell us the length and the slope. We then create 2 other points, point 3 and point 4, use those to create a second line segment, and then we can use these 2 line segment objects to compare them to see if they're parallel to each other. And here you have some hints to help you understand how to start. Right? Obviously, I think you're going to want to start from the top, right? Creating the points first, because you can't have a line segment if you don't have a point class, right? Because the line segment takes 2 point objects. So you want to start with the point. Make sure the point is solid. Once the point is taken care of, then you want to use the line segment class, right? It's probably going to be a much more difficult assignment than everything else you've done so far. So we'll work on this until 7:50, and then we'll code along from 7:50 to 8, and then we'll start the other assignments. Do I have any questions? Okay, if I have no further questions, let's go ahead and give this an honest try. We have 25 minutes. Turn off your cameras and turn them on if you are done. And if you have any questions, come back on camera and ask away. I am here. I'll just have my camera off and mute it. But if you guys have any questions, I'll come back online and we can answer those questions as needed. Talking. All right, we're gonna go ahead and code through the line segment.py. We took about 25 minutes. I know, some of you guys mentioned that you didn't get close to finishing it, and that's okay. And the reason why I'm not giving you guys any more time is for a specific reason, right? So, learn techniques when coding, right? Some people, they will spend 3 or 4 hours on a piece of code and break their head, which is good to some extent, right? But at some point, you have to think to yourself, when is too much? Right, so a good tactic when trying to code and solving issues, specifically stuff like data algorithms, and you're really trying to struggle how to find a solution to stuff like that. If you don't know something, sometimes it gets to a point where you're wasting a little bit too much time. So a good tactic when trying to solve a problem is always to give it a honest try, 20-30 minutes. You set a timer, and you try to solve it. But to avoid falling into a hole where you're just spending 3 or 4 hours trying to break your head and you're going nowhere, it's good to know when to stop and then kind of look for some help, right? And then try maybe again later next week without that help. See if you're able to really understand what you were learning. So that's one of the reasons why we're not going to continue trying to bust our heads to solve this. We're going to go ahead and code along through this, follow through. if you have any questions, do stop me and try to understand what's happening. And then I encourage you guys that afterwards or the weekend, whenever you guys have some free time, give it a genuine honest try again. And then you can reference the video as well if you have some issues where you encounter some kind of law. So let's go ahead and try code through this. We're going to start from the very top, take it one step at a time. The instructions really start right here on line 3, where it starts talking about the point. Right, we're just going to tackle the point first and get that working. So we're going to define a
We
class.
can't see your screen yet.
Thank you very much. I'm going to go ahead and share my screen. Are we all looking at my VS Code? Right on. So we're going to go ahead and define our first class, which is going to be the class point. Right. This is going to need, like everything else, an init method to initialize our class. And like everything is going to require self, so it knows how to talk to itself, so it can set its attributes. And we're going to pass in 2 data members. One's going to be X chord, and the other is going to be Y chord, right? This is what's going to allow our class to know where this point is located at. And then we're going to define these private data members by assigning them their respective arguments. Right, up to this point, nothing's changed, nothing's different. We give it its 2 data members, right? So the init method that takes 2 arguments, an X coordinate and a Y coordinate in that order, right? And uses them to initialize the 2 data members. Next is to define a get method for the 2 data members, get X chord and get Y chord. So we'll say define get X chord, and we're going to return self._X chord. And then we're going to do the same thing for the Y chord, where we return the self._Y chord. All right, good to go. So we got our init method and our get coordinates. Now there's some other stuff here, which is a distance to, right? We can go ahead and kind of make point 1 is equal to points, and give it some make-believe points if you like, to test out that your code is working. We definitely could do this. But it's going to be up to you guys to test out that your class is working. But I know this is working, right? But the next real method that belongs to this point is the distance to, right? And this method takes in a point object as an argument and returns the distance between the point object the method is called on and the one in front of the dots, or sorry, the one in front of the dot, and the point object passed as the argument. So when it refers to the dot, it's referring to this. We have an example where we can say something like point 1, which would be this one, is going to call a method called distance to, and we see here that this distance to method takes a different point as an argument, and it uses these 2 points to identify what is the distance between them. So how does that work? Well, both points should be able to do the same thing, vice versa. So this is a class method, so it should be called distance to. We need self, and it's supposed to take in a point object, which is supposed to be an object, right? Now, how do we find the distance between 2 different points? Well, the formula is given to you. It's something very similar to this, right? Essentially, what we have to do, we'll break it down in steps. We're going to break it up so we can visualize what's happening. We have to subtract an X coordinate from one point, subtract it from the other. And then we have to do that to the power of 2, the result that comes from this. So 0.1 X, which is 5, and 0.2 X, which is 6. So we have to grab both of these X coordinates and subtract one from the other, right? And then we do it to the power of 2, right? So we're going to do that. Subtract 1 X chord from another, and then to the power of 2. Whatever helps you understand what you're doing. And I'm going to call this X diff, right? So I know the difference between these two, right? X diff is going to equal to And I'm going to say that x1 is going to be 0.1 and x2 is going to be 0.2. I'm just going to use the fact that one has the 1 on it and the other one has the 2 on it. So I know which one we're working with. So x2 will be the one that's going to be going into the parentheses when the method is called. So it's going to be the second object. So this should be point object, and I need to get the x. Well, how do I get the x that belongs to the object that's being passed in as an argument? Because this should look something very similar to this of 0.1 dot distance 2, and then it takes in 0.2, right? 0.2 is the object that's being passed in as an argument, right? 0.1 is the point that's calling this method called distance 2, which takes an object, right? So when this method is called, it's going to take 0.2 as an object, which is this right here. And I need to get the x coordinate for 0.2. So how do we grab the x coordinate? Well, both of these are from the same class of point. And they both have these methods of get x coord and get y coord. So I can say point object dot get x coord, and this will return to me the x coordinate from 0.2, which will be 6. And then I have to subtract the x coordinate from 0.1. Well, I'm currently calling this from whatever class called this method. So I can do something like self dot x coord.
Hey, real quick, I found out where I screwed up. I was not adding the parentheses. I think that's where I was messing up when I put something like dot x chord. I think that was my whole screw up.
Yeah, they're methods, but in other words, they're still functions. They require the parentheses to work, right? So because 0.1 is the one that's going to be calling this method, I can say self dot x coord, and that's going to grab the coordinate of the class or object that is calling this method, right? So that's how I get both of these x coordinate within this method. And then once I do this, I need to do this to the power of 2. So I'm going to do asterisk asterisk 2. And that takes care of the first section.
When I was looking at the formula, I wasn't really clear on which came first, whether it's the initial point or the one or the object. I wasn't really sure just based on the formula.
Yeah. So a method named distance2 that takes a point object as an argument. It returns the distance between the point object the method is called on, the one in front of the dot, right? And the point object passed as the argument. For example, if 0.1 and 0.2 are both point objects, then this right here, right, 0.1 dot distance to 0.2 should return the distance between 0.1 and 0.2, and 0.2 dot distance to 0.1 should return the same distance. So either one, whichever one you choose, should do the same thing, right? So it doesn't really matter. You should get the same thing. One you'll get this from one or the other, right? Make sense?
Yeah.
So we have the x diff. Now let's go on to the y diff, and we're gonna do something very similar. Point object dot get y coord minus self dot y coord, right? And I think I did something wrong here. What's going on? Right here. There we go. So I have both this part here and now this part. Now I need to add these two up, both x diff and y diff, and then square root them, which will be the distance. So distance is equal to x diff plus y diff. And then to square root them, as we saw from a previous assignment, we go to the power of 0.5 to get the square root. And that gives me my distance. And now I can return this. Now, let's go ahead and print out how this works. But it shouldn't be far off because there's only a difference of, oh, I'm in the wrong place. CD lesson, was it 08? CD line segment of pi, Python, line segment of pi. Yeah, the only difference is the 1, right? There's a 1 point difference between 5 and 6. All right, now let's make this very different. It looks a little off, and I'm not quite sure how to actually figure out this correct, but I can use a calculator that I found to kind of try and see if the calculator that's already established knows how to do this. Oh, this should be 10, this should be 6, and this should be 20. Let's see if this gives me something similar. And yeah, it's similar, right? It's a little bit off, but nothing too crazy. All right, I feel like this is a little bit more accurate. There's some probably more math that goes into it, but that's okay. But we can use third parties to kind of figure out if our math is correct, which it seems to be like pretty spot on, almost perfect. But that takes care of the first part, right? Of working with a point and gain a distance to. Now we're going to go to the line segment. All this was literally all that working with the distance to. It talks about the formula, the square root, so on and so forth. That's the point class. Is there any questions on anything about the point class? Or how we got the distance to method to work?
Sorry, I couldn't figure out how to get anything different other than 1.0.
You have to change the distance between the x or y's.
Okay. All right.
Yeah, it's okay. Anything else? Okay. We're gonna go ahead and move forward. Now, we got the point taken care of. Let's talk about the line segment. This has to be its own class called line segments. And it has two data members, n.1 and n.2, representing the two endpoints of the line segments, right? In short, guys, right, what we are doing right now is we have a class called point, right? Which has an x and y coordinate, right? It has two data members of x, as y. It has a method of get x and then get y. We use this class to create point 1, and maybe let's delete this. And let's make a circle. There we go. This is point 1. And then we made a point 2 object. Both of these have their own x and y. Right, we have two different objects, both with their own x and y. What we are about to do now is create a line segment that takes in a point 1 and point 2 object to create a class, right? And essentially what it's going to look like something like this, right? That line segment is supposed to represent the point 1 and point 2, right? Does that make sense so far visually of why we're doing this?
Yeah, that's what threw me off in the instructions is I didn't put it together that the arguments for the line segment class have to be objects created by that are essentially point class. I was very confused until I realized that.
Yeah, I know it's a little confusing at first. Only reason I understand it so well is I've done this for a while. I was confused the first time I saw this. So yeah, maybe I should have started with this explanation, and I'll put that on my notes for the next time I teach this. We're essentially replicating this like how you would on some kind of like graph or whatever, where you have two different points. The line segment is supposed to represent 2 points and the distance between them. and we should be able to, and you'll see later in the assignment, is be able to create two different line segments and see if they're parallel to each other because of the points, right? So that's kind of what we're replicating here. So
I have one question.
I have one answer.
Hopefully. Is there a way to force a specific type class as a parameter when defining a class?
What do you mean?
So line segment class right now, line segment you do your initialization, you pass the parameters are self, endpoint 1, endpoint 2. Can you require endpoint 1, endpoint 2 to be class point? Or do you just say they have to be objects, and if they get past the wrong thing, you're just going to throw errors?
You like if you're saying that it has to be, I mean, it'll throw errors. I don't know if you can force that. It's kind of like defining a function. How do I explain it? Yeah, I guess you can't force it, which is why it's very important that you use proper naming conventions to really explain what these functions and classes should be doing. But I don't see any way that you would force that to be specifically a point object. Which is why naming convention is such a big thing. Does that answer your question?
Yeah, it does.
All right, let's go ahead and define the name method. And as we saw here, it has to have two data members. One's going to be endpoint 1 and endpoint 2. Right? That represents the two endpoints of the line segment, which will be point 1 and point 2, right? And we're going to go ahead and assign these. Endpoint 1 is equal to endpoint 1. Then we'll say endpoint 2 is equal to endpoint 2. Both of these private data members, right? A name method that takes 2 point objects as arguments and uses them to initialize the two data members, the endpoints of the line segment. And you could probably do something like object to specify that these are objects, right? To let the person know when you're reading, like, oh, this is supposed to be an endpoint 1 object, or you can call it a point object here, like point 1, point 2, whatever you want to call it. But the proper naming convention and the structure of how you define your class will help alleviate any kind of confusion. But this specifies right here, hey, this is gonna be an object, right? So right? The base class is the class we call it accepts no arguments and returns a new feature that's class that has no attribute cannot be given, right? Okay, yeah. So class object. So this it almost kind of answers your question here, Tim, but it's not specifically a point object, but this tells it has to be an object. Does that make sense?
Yeah, it does.
Okay, right on.
And then on that second line where you're saying self dot endpoint 1 equals endpoint 1, can you just say self endpoint 1 equals point endpoint 1 to force the class?
Point endpoint 1. It won't know what point endpoint 1 is.
It should, because you define the point class above it.
You define that this is supposed to be an object, or I guess a class, right? But the word point isn't defined.
No,
Maybe
I'm saying point like you named the class, and then in parentheses endpoint 1, endpoint 2. Or will that try and create a new one?
like you're saying point dot endpoint 1 like this.
No, I'm talking about line 26, 27.
Right here, you want to say point.
Yeah, with a capital P.
Oh, creates a point.
If you do endpoint 1 right there, open parentheses, endpoint 1. And then on the next line, open point endpoint 2. Will that force the class, or will that try and create a new?
It will try to create a new one.
It'll just throw you're not passing the right.
Yeah, and it'll fail
parameters.
too, right?
Yeah, because you're not passing parameters. Okay.
Correct. I see what you're trying to do. Yeah, this would try to create something new with an object, but because endpoint 1 is an object as we define here, this won't work. Now, if you want to do it that way, if you want to just create a line segment that creates point classes, that's what you're trying to achieve, sure. But you would have to change this to be X and Y coordinates so it knows that, right? But those aren't. The way that this question, or I guess exercise is structured, is that it's supposed to take an object.
Yeah, I guess where I'm struggling here is self.endpoint1 should be endpoint1 dot get endpoint1, but you can't do that.
Well, this endpoint is supposed to be a whole point object. I should have access to both the X and Y locations of endpoint 1. Right? This already has the object created. Are you trying to recreate a whole object in here?
No. I later on I'm not able to reference the inherent properties of the objects that I'm being passed, and I'm not quite sure why.
And we'll see that in a second how that works. Right? So we have here endpoint 1. I'm sorry, I didn't mean to cut you off, Dave, but I'm pretty sure I can probably answer that question a bit with the remainder of this exercise. All right, so we have endpoint 1 that's being assigned to this data member of self.__ endpoint 1, and same thing with the endpoint 2, right? It's going to initialize this object with the two data members being objects themselves. Now we need get methods to be able to grab both these endpoints the same way that the points is able to grab their X and Y coordinates. So we'll say define get endpoint 1 is going to be self return self._ endpoint 1. And the same thing for endpoint 2. Return self._ endpoint 2. All right. Get methods to be able to grab our privatized data members. Next is that we need a method named length that takes no arguments and returns the distance between its two endpoints, right? So this method that line segment will have will be able to tell you how long the line segment is by being able to calculate the distance between both of its points. Right? We're essentially trying to grab the length of this line segment in total. Right? So just like the description said, it should have no methods or no arguments. Can be called length. And it returns the distance between its two endpoints. Well, we kind of already did that if you think about it, right? And it kind of tells you here, this can make use of the points distance to method, right? We get the point itself, the point object has a distance to method that we can use. So we're going to utilize that. We're going to say self dot underscore endpoint 1 dot distance 2 self dot underscore endpoint 2. Because these are both point objects, right? They have this method. These are both point objects. Either one can be on either side. I just need one of them to be calling this method. And we know that this method takes another point object to work. And this will be the distance. Distance is equal to the result of this method. And then we return distance. And let's try it out, right? Because I already know that this works. Let's see if the line segment can successfully replicate the same thing. Right? I'm going to say line segment 1 is equal to, I'm going to call the class. And it's going to take the point 1 and the point 2 as arguments. And then I want to print out line segment 1 dot length. And this should return the same thing as when I grab the distance from point 1 and point 2 by calling it before I created line segment. So I should have this being printed out twice. And we see that it was successful. Do I have any questions on the line segment so far or the length method?
Why don't you have to call the get endpoint 2 when you're using when you're getting the value for distance? You're saying self dot endpoint 1 dot distance 2 self dot endpoint 2. Why are you able to pull that without calling the sub function or the method
Because
rather?
the distance to method is doing that for me.
Oh, god damn it. All right, yeah, that makes sense.
Okay. Yeah, we already made the point object be able to grab its own x and y coordinate. That's how the distance to method was created. So when I run this, I don't have to do any of that because we're using the do not repeat yourself method, right? This will automatically do that for me because I've already coded it. All I have to do is just leverage the same method I have already created within this other method, right? Any other questions? All right. So that takes care of the length method. Next is going to be talking about the is parallel to. But this one is a little bit confusing because at some point I have to figure out the slope, unfortunately. So this is kind of backwards. So I do apologize for that. But we should probably figure out it's going to be the slope method first before we handle the is parallel to. Because you see here that for this method, you'll calculate the slopes of the two line segments and compare them, right? But the method has not been defined yet. So let's define slope first. So define slope. It takes no arguments. And it returns the slope of the line segment. You can find the slope using the formula, which is located at the slope formula.png, which is here. Right? It's going to take the y's of 2 points, subtract them. It's going to take the x's of 2 points and subtract them, divide both of these, and that's going to be my slope. So once again, we're going to get the y diff, and that's going to equal to the y of one endpoint and the y of another endpoint, right? So I'm going to use the 2's and the 1's to reference which endpoint I want to grab. So I'm going to say endpoint 2, so self dot endpoint 2. And here, I actually have to use the get y coordinate because I don't have a method that's already pre-built. So here I have to say get y coord. So I can grab the y coordinate that belongs to this point object, right? Let me just add a note here so you guys don't get confused. These are point objects, right? Don't forget that. Because they're point objects, they have some methods that we can use, which were defined in the object itself, right? Get x coord, get y coord. So this gives me the y coordinate for endpoint 2, and I'm going to subtract the y coordinate from endpoint 1. That takes care of the first part of the top of this division. Now let's do the x diff. And similar to the top one, endpoint 2, but this time we're going to do get x coord minus self dot endpoint 2, or 1, my bad, get x coord. Right? I have the y diff and the x diff, and now I have to divide them. So slope is going to equal to y diff divided by x diff, and we can return slope. Now, I don't know if this slope works, but I got a calculator for it, so let's give it a try. All right, the 2 points are known. So the x1 and y1, so this is going to be 5, and this is 10, and this is going to be 6, and this is 20. We can calculate it. And what the heck is my result? Result, slope. What is the slope? 10? Is it 10? No. Can someone explain anything that I might be missing? I'm not really good with math. Oh, I think right here. This is the slope right here. Kenny came off of mic and went back on mute.
So the slope is 10. That means for every 10 times it rises, it goes to the right one time.
Oh, okay.
Which it's a fraction. It's rise and run. So every time it goes up 10, it goes 1 to the right.
All right, Kenny, yo, coming in clutch. Yo, I've been out of high school for years, man. Thank you, Kenny, for that. I appreciate it. I will remember that. And he was right. Look, I ran the slope method and it gave me 10. That's awesome. Okay, I did not know that. As a matter of fact, every time I run it, I've never even used the calculator. This is the first time I used it just to make sure that we can actually see something that's correct. And I'm glad I did, because I learned something new. Math is not my strong suit. As you can see, you don't need math, or you don't need. Let me rephrase that. You don't need to be good at math to be a software developer, because half the things that you do don't ever really need math. But for this exercise that we're doing here to teach you guys how to code, we're using math. But you don't necessarily need math to make, applications.
You know, it goes to show collaboration's good. It's good we had Kenny so he could make sense of that.
Yo,
'cause I
right
wouldn't
on. That's
even
what I'm
know.
talking about. Yeah, absolutely. That's what I'm talking about. Good stuff. So there we go. So slope's working. Let's go ahead and move forward. All right. So now that we have the slope, we can go ahead and target the is parallel to. So let's go ahead and come down here. We're going to say define is parallel to. And let's see what it takes. It takes a line segment object as an argument, right? So it's going to be very similar to the distance to, where a line segment can call the parallel to and take a different line segment to figure out if they're both parallel. So inside this method, we're going to say line segment, and it's going to be an object. Right, so it has to take a line segment object. Right, it returns true if the line segment the method is being called on is parallel to the one being passed as the argument. Otherwise, it should return false. For example, if line segment 1 and line segment 2 are both line segment objects, then line segment 1 dot is parallel to, with line segment 2 being passed as an argument, should return true if those two lines are parallel, but otherwise should return false. For this method, you'll calculate the slopes of the two line segments and compare them. If the two slopes are equal, then the line segments are parallel. Otherwise, they are not. Right? This can make use of the following slope method. Right? Remember that you shouldn't test two floats for exact equality because of possible lack of precision or round off errors. Instead, if we want to compare the floats to see if they're equal, we can use this little formula here, where we take two different numbers, so two different slopes, we subtract them, and we use the absolute method, and then we check if they're less than 0.00001. If this is true, they're accurate, right? So let's check it out. Let's go ahead and see how this works. We have slope 1 is equal to self dot slope. Can I do self dot slope? I would say I can. Self dot slope, because this is going to get the endpoint for whoever's calling this. We can say self slope 2 is equal to line segment dot slope. And then we can say is parallel is equal to, and we can say absolute slope 1 minus slope 2 less than 0.0000001. Return is parallel. This is going to return a Boolean, right? Because we're doing a comparison, right? It's going to do the math. It's going to subtract one slope from the other. It's going to convert it to the absolute value. And it's going to check, is it less than 0.00001? And it's going to either tell me true or false. And then I can return that. Now, we need to be able to make another slope. Another line segment. So we need two other points. So we'll say 0.3 is equal to. Actually, let's use the example here. Let's go ahead and copy and paste this and put it here. And notice that this creates 2 points. It checks the distance between those. Let's comment this out because we already know this how that works. And then it creates a line segment. We've seen that how the length and the slope work, so we can comment this out. But here we have the other points and then other line segment. And now let's check if this is parallel and run it, and we get false. Now I don't know if that is correct. So let's see if we can find a slope calculator or is parallel calculator. I wonder if these have anything like that. Parallel line, calculators, acceleration. I guess we don't have one. I'm trying to see if there's an easy way of doing this. Well, I've never used any of these. We can say, let's see, slider. What is this doing? If anyone has any good page we can use, please let me know. I guess we could probably use this one. Table, solve. Anyone coding along, do you guys have any way where you can confirm this is parallel? All right, I guess you're gonna have to take my word for it. Well, yeah, I have no actual way to ensure because I don't know just by looking at these numbers if they are parallel. I would have to kind of graph it out, but I mean, I could only assume. What if we do something like 2 and 10? Then we say 4 and 10. The y coordinate is height. And the x is left and right. So it'll be 5, 10. Now we should be able to do something very similar, right? If the x, we can say this one's 10. We can make this 20. We say 20 and 40. Will this work? I don't know. I'm sorry. I'm not too good with math or graphs and stuff like that. If anyone finds a way to test this, please let me know. Because I don't know how we can find if something is actually parallel without doing some kind of line graph. And
So
I don't.
for your
Uh-huh.
your 0.1 and 0.3, put 0, 0 for your 0.2 and 0.4 do the same numbers. They don't have to be the same number. Like 0.2 could be 5.5 and 0.4 could be 7.7. That'll give them a slope of 1, which is a 45-degree angle.
Like
Even though
this?
yeah, 7.7. Yeah, those are identical slopes.
Oh, there we go. Thank you. Sorry, it's hard for me to visualize it. That's why I always draw so much, because I know that I struggle with visualization when it comes to coding or problem stuff. So I like to draw it out to ensure I understand it. So kind of seeing this it's a little difficult for me. But thank you, Tim, for your contribution. That was able to show here that this is working. It's true. And that's going to conclude our line segment. .py. Do I have any questions on any of the code besides the math, right? But any of the code or how we achieve this, how the methods are working or they're interacting with each other.
I think the major confusion on me was I was expecting once I put the code into VS Code that the objects that I was passing as parameters, I would be able to pick up their methods automatically in code. And it doesn't do that. You just have
What
to
do you mean?
trust. Like when when you're typing and you have a recognized method, it'll pull up a little list of things and it'll narrow down as you type.
Yeah,
I was expecting past parameter objects to be able to do that, and they don't.
I think there's extensions that could help you with that. But
So I was writing the correct code, but it wasn't doing that, so I thought it was wrong.
yeah.
But now I know that, so I've learned something.
No, I mean that's understandable, but I do think there are going to be some extensions out there that if you want to make things like that easier, to make coding easier like that, then you can definitely install some of those. I mean we've installed some of the extensions that kind of helped already, but there's more out there. So that I would kind of look it up, see what extensions you can find, um, and I'm sure there is. We have AI these days, so I'm sure there's something that's smart enough to be able to see if you've already defined it somewhere else. It can probably auto fill it for you, right? But yeah, that's going to complete today's class. Do I have any questions before we conclude here?
I
Anyone?
guess one thing I'd be concerned about, because the math is just kind of over my head, is like, I when I was working through the problem, I was trying to go step by step, and just make sure I'm correct, but before I move on. Because I noticed as we're coding, it just seems like we're just typing a bunch of stuff, then crossing our fingers and hope everything works. But when I code, I just try to do like piece by piece by piece by piece. And I'm not sure by working through this example, if I could do that just because the math seems a little over my head.
Yeah, and that's understanding, right? I'm not so good with math too, as we just saw that in real time. We have some other assignments. The next one's going to be a streaming guide, right? So we're going to replicate stuff like creating Netflix or like Blockbuster, right? Where we can save some movies, visualize what movies have what, and channels and stuff, who's rented out what movie, which might be a little bit easier to understand and visualize. So I'm sure you'll probably do better in that one. Maybe the assignment was a little bit too complex with the fact that it's introducing math, and not all of us have a strong study in math. So I can understand that, Jason. Hopefully, this next assignment is going to be a lot easier for you. But we will not get to that one today because it's going to be just as big as this one.
Yeah, I mean, I don't say because I think I suck at math. It's just I haven't done slopes and all this in like 20 years, so I'm just not gonna know how to do it.
That's understand. I'm not saying you suck at math. I'm just saying like, hey, like you said, some of us have not seen it forever, and that's okay. I personally do suck at math. So that's my excuse for sure. But all right, I'm gonna go ahead and stop the recording because that concludes the official lecture.